Let's discuss the problems from 11 to 17. These problems are for 4 marks and mostly appear in the CSIR NET examination. So in CSIR NET examination we don't have much time to analyze the problem. So I will teach you how we can rule out one option and we can reach up to the correct option. Okay, so we are not going in detail, but we are going to rule out the wrong options and we'll assign the correct option. Okay, let's start with the problem number 11. Deduce the structure, and the molecular formula is C7H4O3NCl. Okay, so in the molecular formula we have N, Cl and O. So what are the possibilities of the functional group? We can judge it by IR frequencies. So 1770 is typical frequency for either it is for ester or for acid chlorides, and for 1530 is for NO2. Okay, 850 is for paradiesubstrate benzene ring. So you might think why I am so sure. I will request you to watch my video on IR frequency. In that I have explained how we can remember or assign the IR frequency to the functional groups. Okay, it's very simple video. So we have two options, ester or acid chloride, NO2 and paradiesubstrate benzene ring. So in the first option we have COCl and NO2. The paradiesubstrate benzene ring also can be confirmed by PMR, that is 2H and 2H, that means is a symmetrically substituted benzene ring. So if we go for first option, it is not symmetrically substituted even though it have COCl and NO2. So this option is ruled out. Second option is paradiesubstrate benzene ring but don't have COCl functional group. So this will not show the IR stretching frequency around 1770. So this also ruled out. Second is not a paradiesubstrate benzene ring and don't have COCl functional group. So this also ruled out. So in the last option we have COCl, NO2 and this is a paradiesubstrate benzene ring. So we can go for the fourth option. So correct option is option number 4. Okay. Now let's go for the next problem. Assign the correct structure. Molecular formula is C7H12O4. 1740 is a typical signal for esters. Okay. So we need to look for the ester. And the PMR showing 2.6 singlet at 2H. Okay, 2.6 singlet of 2H, that means CH2 is attached to the sp2 carbon or carbon-carbon or carbon-oxygen double bond. That's why it's showing at 2.6 and singlet. That means there is no neighboring proton around this CH2. So let's look for this kind of CH2 and ester molecule. So in the first option there are ester, but this CH2 is coupling with this H and this H. Okay, so it is not showing singlet. In the next option also this CH2 is not showing singlet. That's why it's ruled out. In the third option we have CH2 which is showing singlet, but friends, our signal is at 2.6. You can see from the NMR data the signal is at 2.6. But if we go for third option, this CH2 is attached to heteroatom, that is two oxygens are there. So this will go downfield around 3.9 to 4.5. okay, so this will go downfield because of this oxygen group. So this option also ruled out. So in the last option we have this CH2 showing singlet and is attached to the carbonyl group. So and the correct option is option number 4. Now the next problem is deduce the correct structure. C8H10O and the IR is showing 3360. Okay, and 1610. So 3360, and in molecular formula we have oxygen. That means this signal is definitely for the OH group. Okay, so in from IR we have OH functional group, and from NMR what we can get it. So in NMR 1.6 broad singlet, 4 mm. Okay, so most of my students confused with this 3.8 mm, 8 mm, 7.9 mm and 20 mm. So sometime to confuse you guys, they gives these values in this digits. Okay, so 3.8 is nothing but 4. You just rounded it up to 4. So one proton will be 4 mm, 2 will be 8 mm, 7.9 again you round it up to 8. So it will become 2 protons. So 20 mm is 5 protons. So 5 protons multiplied 7.2, that means it's a mono substituted benzene ring. Okay, this is the OH broad singlet, 1H is OH, and 2.8 triplet of 2H, I mean CH2 attached to the sp2 carbon, and 3.9 triplet 2H, that means this CH2 is attached to the oxygen, that means CH2 to the sp2 carbon and CH2 to the oxygen and monosubstrate benzene. Let's look for this kind of data. So in this we don't have CH2 group, so this option is ruled out. In this option we have monosubstrate benzene, two CH2s, one is attached to the oxygen, another attached to the sp2 carbon. That means this option looks like a correct option, but let's consider other options also. In this we have CH2 but this will show singlet because of molecule have symmetry, so we don't have triplet of CH2 in this molecule, so this also ruled out. In this also we don't have CH2, so the correct option for this problem is option number 2. Okay, so let's look for the next problem. So the next problem is reduce the structure, and the molecular formula is C7H5O4N. I are showing the peak at 3400, 1710, 1530. So typical peak around 3400 is for OH or NH, 1710 is for acid, aldehyde or keto, 1530 is typical for nitro group. So look at the problems. We have acid, acid, acid and acid. So there is no possibility of keto or aldehyde. So this 1710 is for acid and this 3400 is for OH and 1530 is for NO2. Okay, now let's compare the PMR data with the molecules. 7.72, 1, 2, 3 and 4. We have 4 peak in PMR for the benzene ring and one is for the acid proton. Okay, acid OH proton. So there are 4 different kinds of proton in benzene ring. That means there is a less chance of paradise substrate benzene ring because these two will show one signal and these two will show one signal. We have 4 different kinds of protons. So let's rule out the first option. Second is we have only 1, 2 and 3 protons in PMR, but we need 4 signals or 4 different protons in aromatic region. Third and fourth option have 4 different kinds of proton, 1, 2, 3 and 4 different kinds of proton. Also in the fourth option we have 1, 2, 3 and fourth option. So which one among these is correct option? Let's compare the PMR of this molecule. 7.72 doublet of doublet and J value is 8 Hz and 8 Hz. That means this proton which is shielded among these 4 proton, that means this is a shielded proton and have 2 orthoprotons. Okay, orthoproton. This is ortho coupling for this PMR value. Okay, 8 Hz is for ortho coupling and 8 Hz is for ortho coupling. We can round it up to 8 Hz. 8.1 also rounded it up to 8 Hz. So this shielded proton have 2 orthoprotons. Okay, nothing else is around this proton. So let's compare. So already we ruled out the first option, second option. Now look at the third and fourth option. Third and fourth option. In this we don't have any proton which have only 2 orthoprotons because this have only 1 ortho. This have 2 ortho but 1 meta. This also have 2 ortho and 1 meta, and this also have 1 ortho and 1 meta. So only in the fourth option we have this proton which have 2 orthoprotons showing coupling constant around 8 Hz. Okay, this will show 8 Hz, this will show 8 Hz. So from first signal we can conclude that the correct option is option number 4. Let's go for the next problem. Choose the correct option. C6H5NCl2. Okay, we have chlorines and nitrogen. That means there are chance of functional group containing nitrogen. Okay, and the IR is showing around 3300, 3400. It is for the OH or NH, but in formula we have only nitrogen. That means NH2 is present in the molecule. 5.10 broad singlet exchangeable 2H. That means we have NH2 in the molecular formula or molecule, and the PMR signals around aromatic region are only 3 aromatic protons. Okay, 3 aromatic protons. That means other 3 positions are substituted with the other functional group. Means we have tri-substituted benzene ring. We have tri-substituted benzene ring. Now look at the any one signal from NMR. Either we can look for the upfield or downfield. So 7.23 is downfield among these three. So look for the downfield proton. So which one among these three is downfield? Of course, one which is meta to the NH2 and ortho to the chloro. This one is downfield. That means it will show at 7.23. But J value is only 2 Hz. That means it have meta coupling. Okay, meta coupling. So the downfield value have no meta proton. That means this option is ruled out because of this 2 Hz coupling is only for meta coupling, and this proton don't have meta proton. So this option is ruled out. Now this is a trisubstrate benzene ring, but in PMR value there is no CH2. That's why this option also ruled out. In the third option, this is also trisubstrate benzene ring, but is a symmetrically substrated benzene ring. That means this CH and this CH will show only one signal. That means we have only two signals in the aromatic region. This 2H will be show one signal and the para will show one signal. Only two signals in aromatic region. That means this also option ruled out. That means this fourth option is correct option. Let's analyze it. We have this downfield protons at, we said it is at 7.23. So let's compare the PMR data. So due to this chlorine group, this is a downfield among these two. So this is 7.23 proton, only have one meta coupling with this proton. That means this is showing only meta coupling having 2 Hz coupling constant. Okay, 2 Hz coupling constant. That's why this option is correct option. And we can compare also other signal in the PMR, but from one signal we can conclude that this is a correct option. Now the next problem is choose the correct option. C8H15NO and the IR frequency is 1750. As everyone knows that 1750 is typical for keto, or we can say aldehyde or keto. So let's compare the IR data. So some of my students might say, why not acid? Because if we have acid, it will show the peak around 33 or 3400. Okay, 3300 or 3400 it will show peak of OH. So only possibility of aldehyde and ketone. And PMR data is showing 1.08 doublet of 6H, 7 Hz. So either it might be a symmetric or asymmetric molecule. 6H, that means two CH3 groups are there. Let's see its coupling partner. 7 Hz is here, 7 Hz. This is one proton showing septate. That means it's not a symmetric, but it's a CH3 and CH. That means it's an isopropyl type molecule. Okay, isopropyl unit might be present in this molecule. And these two signals of 4H, 4S, that means there are four CH2 groups. This 2 CH2 and these 2 CH2s are in the symmetric way. Okay, let's see the options. In the first molecule we have these two showing CH3 doublet, but as you know that 6H we have doublet, but 1H have septate. That means this 1H will not show the septate, it will show quartet. That means the first option is ruled out because of absence of septate signal. In the second option we have these two CH3s showing doublet and this one is showing septate. That means this looks like a correct answer, but let's compare with the CH2s. This CH2 showing triplet and these two CH2 showing triplet. That means these are symmetrically arranged in the molecule. That means it looks like our problem, that is 2.4. Due to carbonyl it's showing triplet around 2.45 4H, and 2.8 due to nitrogen this triplet is of this CH2. That means the correct option is option number 2. Why not 3? Because in this molecule we have CH2s at due to nitrogen, but these CH2s will appear around 1.1 or 1.2, not below the 2. So this signal is absent in the PMR data. So this option is ruled out because of these CH2s will not go downfield up to 2. Okay, because they are only attached to the sp3 carbon. This also completely ruled out because we don't have NH2 signal in the IR data. So let's assign the second option. Okay, the correct option is option number 2. And the last problem in this test was choose the correct option for 4 marks. It's a C5 H11 Br. Featureless about 210, that means there is no conjugation. IR showing nothing significant, that means there is no significant functional group. And PMR data is showing 1.02, 24 mm and 6.65, 4 mm, 8.85, 8.3 mm. So student, you can round it up to 8. So 4 will be 1 proton, 24 will be how much? 6 protons, these 2 protons, and again these are 2 protons. So we have this kind of data with the PMR. So let's see one by one. 1.02, that means is the most shielded proton of 6H. So there is no option for 6H proton in this molecule, so this option is ruled out. Here there is option of 6H showing doublet, okay, 6H showing doublet, and another CH2 showing, this will show 2 plus 1 3 quartet or multiplet, okay. So we have multiplet. Let's see the last signal, 3.4 triplet of 2H, okay, triplet of 2H, and it is around 3.4, that means it is attached to the heteroatom. So this molecule is fulfilling all the condition. This CH2 is showing triplet at 3.4 because of this Br. Let's also analyze the other problems. 6H doublet but no CH2 signals, that means this is ruled out. Here we have 6H singlet, not doublet, so this also ruled out. So correct option for this problem is option number 2. Understood? So thank you very much for your patience, and if you guys are enjoying my lectures or videos, please like and subscribe my channel. Thank you.